This is MSJ Chem. In this video, I'll be looking at inductively coupled plasma mass spectrometry. Inductively coupled plasma mass spectrometry is a type of mass spectrometry which is capable of detecting metals at very low concentrations. It combines a high-temperature ICP, which is an inductively coupled plasma source, with a mass spectrometer. The ICP source converts the atoms of the elements in the sample to ions. These ions are then separated and detected by the mass spectrometer. An inductively coupled plasma is a plasma that is ionized by inductively heating the gas with an electromagnetic coil. Argon gas is electrically heated to a high temperature plasma, to temperatures greater than 6000 Kelvin. Plasma is one of the four states of matter. It consists of free electrons, positive ions, and neutral atoms or molecules. In this diagram, the blue flame is the inductively coupled plasma. The sample to be analyzed passes through the inductively coupled plasma. Due to the high temperature of the inductively coupled plasma, the sample is ionized. Next, the ions enter into an electric field and are separated according to their mass-to-charge ratio. Here we can see an example of a mass spectrum. On the y-axis, we have the signal intensity of the ions. On the x-axis, we have the mass-to-charge ratio. The signal intensities are directly proportional to the concentrations of the elements in the sample. In this sample, there are higher concentrations of lithium, sodium, and chromium, and lower concentrations of tin, silver, and cadmium.